Hello everyone, thank you for taking the time of your day to watch this video, and that means, hey, you want to learn a little bit more about math. Well, I am here to help you. My name is Cameron, and today I want to be talking about taking the derivative of a composite function. Now what a composite function is, that is literally where we have a function inside of another function. So, right now I am actually using the tool Geogebra, Geogebra Classic, and that is something that you can actually find online. You can just go to their website and you can pull this up, or you can download the free software. And I have the tabs. If I go up here to the three little bars up at the top right corner, I go to View, and I make sure I have CAS, Tool, and Spreadsheet. So CAS is a calculator that I will be using later on this video, and Spreadsheet is very similar to a spreadsheet that you see in Excel. Now the cool thing about Geogebra, it can be used for many different things aside from the spreadsheet and calculating. I can also use it to form integral functions, graphing as you would see on Desmos, and a lot of other things, and animations. Really cool stuff. I hope you take the time to learn and acquaint yourself with it. But today I have a few examples of composite functions right over here. And the way that a method that I'm going to show you is how to take the derivative of a composite function is to split it up into two parts, right? So I have my f of x and g of x, the two separate expressions. Now my f of x is going to be designated by what's inside the parentheses, alright, the inside. So I'm actually going to type in for f of x 3x plus 5. Boom, right? That's my f of x. Now g of x is what's on the outside. Now I'm going to write x to the power of 5 because I need something raised to the power of 5. In this case, x is just a placeholder for what's on the inside of the parentheses, or really just the parentheses themselves, right? So don't let that x in g of x confuse you. It's not the same as taking this x, right? So what if I want to find the derivative of my f of x function and my g of x function? That's what I'm going to need later on. As you can see, that's my f prime and g prime of x. So what I can do, I can come over here to my CAS tool, handy dandy CAS tool, and actually type in the function that I want to do, or the action I want to take. So I can quite literally type in derivative, and Geogebra comes up with, kind of like you would see in Excel, it has all these different options. I can take the derivative of expression and a variable, or expression of a variable with respect to a number. But I just want to do the one with expression, so I can either type in 3x plus 5 in there, or I can simply put what cell it is in. So it is in B2. So B2. It also is important to note that you should capitalize your letters whenever you're calling something from a spreadsheet, and I hit enter and it gives me 3. And that is indeed the derivative of 3x plus 5. It is simply 3. Fantastic. Now, what if I wanted to take the derivative of g of x, or x to raised to the power of 5? I can do the same method again, and I can just call it, so C2, hit enter, and boom, it gives it to me right there. 5x to the power, whoops, it's not typing. Let me make sure I switch between tabs here. So it would be 5x to the power of 4. Enter. Fantastic. Now, the reason why I split up my original composite function was because I wanted to make sure I took the derivative of the inside and the derivative of the outside. Now, to find my overall y prime, or the derivative of this expression, is to multiply my f prime of x and g prime of x, right? So I'm going to multiply the products that I have here. So, the derivatives I have here. So 3 times 5x to the 4th. Now I can do that over here with my handy dandy CAS tool. I can simply call in the function, or the cell in which they're in. So let's see if I can try capitalize D2 times, and that would be E2. And boom, it gives it to me right there. It knows what's in those cells, and it can calculate it there for me. So I now have 15x to the fourth. Now remember, I mentioned earlier that x in g of x, in terms of g of x, is just a placeholder for the actual whatever is inside the parentheses here. So I'm actually going to write, instead of 15x to the power of 4, I'm going to write 15 times whatever is inside the parentheses here, so 3x plus 5 to the power of 4. And boom, that is the derivative of my initial function, 3x plus 5 to the fifth. Now, let's go through and see another example of how I can do this for other functions, right? So make sure for my new function, 3x plus 5 to the power of 6, I would have my f of x, which is 3x plus 5, my g of x, which is x to the power of 6. Now the derivative of 3x plus 5, we learned earlier, is 3. And the derivative, if I want to find that, I can just come over here and type it in. I already know it, but I just want to show y'all. I promise you I know it. I just want to show you how to use a cast tool over here. So I can just type in C3, and boom, it gives that to me. So I have 6x to the power of 5, 6x to the power of 5. Oh yeah. And now again, I want to multiply my derivatives, f of x and g of x. So I multiply them together, and that is how I get my actual new y prime, or the derivative of my first composite function. So once I multiply them together, 3 times 6, what is that? That is 18. So 18, instead of writing x, I would write whatever was in my parentheses to begin with, 3x plus 5 to the power of 5. And boom, that is my new derivative. So you can actually go through and kind of think, you know, what's on the inside of the parentheses, what's on the outside of the parentheses. I'm going to skip ahead because I want to make sure I have time in this video to show you some trig functions, how you might go about doing that. So same thing with f of x is whatever is inside the parentheses. So in this case, it is 4x. And on the outside, I have my function sine, with x being the placeholder. So if I want to find the derivative of 4x, I can really either type it in here, or for the sake of time, if you know it by heart, or know how to do derivative actions, it is just simply 4. And if I want to know, say I'm not really that well versed in my trigonomic derivatives and integrals, so I can type in derivative, no to spell, I promise, derivative of, say, C6, right? C6, cell C6. Enter, and boom, it gives it to me cosine x, right? With x, again, in terms of g of x, being a placeholder. So now I multiply the two derivatives together, and I should get 4 cosine x as my y prime, right? But also another cool thing that I can do, if ever you're using Geogebra, or you just want a quick, find a quick derivative without doing like time pressure and whatnot, I can quite simply type in derivative, and as I did earlier with calling in these cells, I can do the same thing here. So if I want to take the derivative of, say, cell A6, I can type in A6, and boom, it gives it to me. Oh, I forgot my 4x on the inside, and my apologies. So it should be 4 cosine with 4x on the inside. See, it's a great way to check yourself, because we all make mistakes. But say if you were pressed for time and you really need to learn how to do this, this method here is a great way to see what exactly is happening. So if I recognize the pattern, I take with the derivative of the inside times the derivative of the outside. A way that I would write this would be, say, y prime. In order to find, well, let me write it over here. In order to find my y prime, it is actually the derivative of f, so f prime, or f of x, times the the derivative of my g of x, g prime of x, all that smushed together, so whatever that product would be, and times whatever my original function was for y. So let's just designate that as x to the power of n for any number, just a number, plus a constant. Oh, let me make sure I designate my parentheses here. I know I have a lot of parentheses, but it'll be worth it. Hold on. So plus a constant, whatever constant that may be, and it would be raised to the power of, I'm going to just write p for power, minus 1. So whatever for my power was in my initial y equation, right? So that, if I can expand it out here, so this actually is a general rule whenever you're taking the y prime of something. So I really hope that this video was able to help out a lot. And if you would like to test this out yourself, you're more than welcome to. If you have any questions, be sure to comment down below, and I hope to see you guys next time.